Hello everyone, this is my third lecture on numerical analysis. In this lecture, I will discuss factorial notation. First come to the definition. The product containing n factors like x, x minus h, x minus 2h, up to x minus n minus 1h is called a factorial polynomial of degree n and is denoted by the symbol x power small bracket n. Thus x power small bracket n is equal to x, x minus h, x minus 2h up to x minus n minus 1h. In particular, x power small bracket 1 equal to x, x power small bracket 2 equal to x, x minus h, x power small bracket 3 equal to x, x minus h, x minus 2h, etc. Now come to the example. Express 2x cube minus 3x square plus 3x minus 10 and its differences in factorial notation. The interval of differentiation being unity. That means we have to take h is equal to 1. So this is the first method or the direct method. In this, let fx is equal to 2x cube minus 3x square plus 3x minus 10, which is can be written as capital A x factorial notation 3 plus bx small bracket 2 plus cx small bracket 1 plus d, which by the definition of factorial notation can be written as a x, x minus 1, x minus 2 plus bx, x minus 1 plus cx plus d. Take it as equation 1, where a, b, c and d are constants to be determined. From equation 1, putting x equal to 0, we will get d equal to minus 3. Again putting x is equal to 1, we will get c plus d equal to minus 10. After simplifying, we will get c is equal to 2. Again putting x is equal to 2 in equation 1, we will get 2b plus 2c plus d equal to 0. After putting the value of c and d, we will get b is equal to 3. And equating the coefficient of x cube from both sides of equation 1, we will get a is equal to 2. We can also find the value of a by substituting x is equal to 3 in equation 1. Thus a equal to 2, b equal to 3, c equal to 2 and d is equal to minus 10. Hence putting the values of a, b, c, d in equation 1, we had fx is equal to 2x small bracket 3 plus 3x power small bracket 2 plus 2x small power 1 minus 10. Again by the rule of simple differentiation, we get delta fx 6x square. As we know, the differentiation of 2x cube is 6x square plus 6x plus 2. Delta square fx is equal to 12x power 1 plus 6 and delta cube fx is equal to 12. Now this is the another example. We have to represent the function fx is equal to x to the power 4 minus 12x cube plus 24x square minus 30x plus 9 and its differences into factorial notation. So in the previous example, we have fx is equal to x4 minus 12x cube plus 24x square minus 30x plus 9, which can be written as ax power small bracket 4 plus bx power small bracket 3 plus cx power small bracket 2 plus dx power 1 plus e. Give it as equation 1, and this can be written as ax x minus 1, x minus 2, x minus 3 plus bx x minus 1, x minus 2 plus cx x minus 1 plus dx plus e. Take it as equation 2, where a, b, c, d and e are constants to be determined. In equation 2, putting x is equal to 0, we will get d equal to 9. Putting x is equal to 1, we will get d equal to minus 17. Similarly, putting x is equal to 3 and x is equal to 2, we will get c is equal to minus 5, and after simplifying, we will get b is equal to minus 6. And lastly, comparing the coefficient of x to the power 4 on both sides of equation 1, we will get a is equal to 1. Thus a equal to 1, b equal to minus 6, c equal to minus 5, d equal to minus 17 and e equal to 9. Now putting the values of a, b, B, C, D and E. In equation 1 we get fx is equal to x power small bracket 4 minus 6 x power small bracket 3 minus 5 x power small bracket 2 minus 17 x power small bracket 1 plus 9. After simple differentiation, delta fx is equal to 4x cube minus 18x square minus 10x minus 17. Delta square fx is 12x square minus 36x minus 10. Delta cube fx is 24x minus 36 and delta 4 fx is 24. Now this is a theorem on factorial polynomial, which is delta x power small bracket n equal to nh x power small bracket n minus 1. So let fx is equal to x power small bracket n, then delta x to the power n is equal to, by the definition of forward difference, delta fx is equal to fx plus h minus fx. So delta x small bracket n can be written as x plus h power small bracket n minus x to the power small bracket n. By the factorial definition of factorial polynomial, x plus h power small bracket n can be written as x plus h, x minus h, x minus 2h dot 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 x minus n minus 2h, and minus x power small bracket n is the value of x power small bracket n is x minus h, x minus 2h dot 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 x minus n minus 1h. By taking the common terms, we will get x minus h, x minus 2h, x minus n minus 2h as common, and we are left with x plus h minus x minus n minus 1h. So this, after simplification, we will get x minus h, x minus 2h dot 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 x minus n minus 2h into nh, and the terms x minus h, x minus 2h up to x minus n minus 2h by the definition of factorial polynomial can be written as x power small bracket n minus 1. So delta x power small bracket n can be written as nh x power small bracket n minus 1. Similarly, delta square x power small bracket n is delta bracket delta x power small bracket n. By substituting the value of delta x power small bracket n, we have nh x power n minus 1, and again substituting the value of delta x power small bracket n, we will get nh n minus 1 h x power n minus 2. So we finally get n minus 1 h square x power small bracket n minus 2. Proceeding in a similar manner, we will get delta cube x power n is equal to n minus 1 n minus 2 h cube x power n minus 3, and so on. Delta n x power small bracket n is factorial n h to the power n. If h is equal to 1, delta x power small bracket n is n x power n minus 1, delta square x power small bracket n is n minus 1, x power n minus 2, and so on. Delta n x power n is equal to factorial n. Thank you.